Good evening to all of you, Radhe Radhe friends. In this particular video, we are going to learn about the counter current mechanism. Counter current mechanism, which is present in your kidney. And let's see, there are two main components we have to learn. First of all, we will see the meaning of this word, these two words, counter current. Counter means what? Whenever the things are going in an opposite direction, that is the meaning of counter, right? And current means we all know flow. So opposite flow is going to happen in the kidney, and these opposite flow. First of all, let me draw a loop of Henle for you. This is loop of Henle of the nephron. Okay, this is, we all know, this is descending limb DL. This is ascending limb of loop of Henle. Here, for the convenience, I am drawing a loop of Henle in blue color, and parallel to it, I am drawing a blood vessel which runs along with the loop of Henle, and that is called as the vasa recta in a black color, like this. So I hope it is visible. Yes. So this is vasa recta, and vasa recta has descending loop here near to the ascending loop of Henle, and ascending loop here L sorry near to the descending loop of Henle. Okay, so these two are opposite. So see, we all know that filtrate is going to form sorry go it will go from the descending loop to ascending loop in the loop of Henle, like this way. So this is the flow, we can say, flowing this is the filtrate flowing in a opposite direction from descending to ascending loop, and that's why the term is counter current, because the filtrate is flowing in opposite direction of the loop of Henle. Again, in the vasa recta, the blood is flowing from descending to ascending, like this. So it is also in a opposite flow, opposite direction. That's why the name is opposite counter current mechanism. Okay, so let's see how it works. We all know that in the blood, suppose this is a cortex region, this is medulla region, this is the outer part of medulla, this is inner part of medulla. So as we all know, filtrate goes down into the medulla in the loop of Henle. It is going to lose water. We have already talked about it, because loop of Henle is permeable to, this descending loop is permeable to water. So that's why the water is going to flow outwards in descending loop. So because it is flowing outwards, because it is permeable, descending loop is permeable to water, what is going to happen, whenever filtrate is going down into the medulla, filtrate will become concentrated. Okay, and the osmolarity will increase as it goes down into the medullary part. So here we get 300 milliosmol osmolarity in the cortex region per liter. So as we go down, because it is losing water, the solute concentration increases. We will see increase in the osmolarity, 400, 600, 900, and finally 1200. It reaches 1200 milliosmol per liter. as it into the inner part of the medulla, filtrate. And we all know that ascending loop is permeable to electrolytes. So whenever the filtrate will go in the upward direction in the ascending loop, it is going to lose NaCl, right? So as it goes upwards, it will lose electrolytes, so it will become diluted. So 900, 600, 400, and as it reach to the up into the cortex region, it will again come back to the original osmolarity it has. So this is going to happen in the loop of Henle. Then what is vasa recta is doing here? Vasa recta, as it is going to take this NaCl into it. It is permeable to NaCl. So because it is taking solutes, the blood which is flowing into the vasa recta in the descending limb, it will increase its osmolarity. 400, 600, 900, finally 1200. And in opposite direction, as it goes upwards into the ascending loop of vasa recta, it is going to throw that NaCl into the interstitium. So it will again diluted. The blood will again dilute as it is moving upwards the ascending loop. These are the 2-3 things you have to remember here. Wherever filtrate is moving down, it is going to concentrate it up to 4 times concentrated, which means 1200 milliosmol per liter. As it filtrate moves upwards, it will be diluted. As blood is going downwards, it is concentrated. It is going upward into the vasa recta, it is going to do diluted. Okay, so this is happening, and this creates a gradient into the kidney. This flow of substances from here to there, it creates a gradient which helps filtrate to move inside the tubules and sometimes produce concentrated urine. How it is produced, that is what we are going to study in the next videos. There is one more thing you have to remember here. We all know that there is collecting tube here after the DCT. Collecting tube is again going to release urea from it. Some amount of urea will be thrown out of the collecting tube, or we can say will diffuse into the medullary interstitium. It will be taken by the thin part of the ascending loop of Henle. Thin part, we all know that ascending loop has a thinner part here and thicker part here. Thin part will take this urea, and again that urea will be recycled. This is urea recycling is going to happen. So these are the things you have to remember in the counter current mechanism. I hope it is clear to you. We will stop here and we will meet in the next video. If you like this video, please hit the like button and subscribe to my channel to get more and more videos like this. Thank you so much.